Okay, ladies and gentlemen, this is the last one in 8.2. We're looking at hypothesis test for proportions. This time we're going to look at a two-sided test, and then we're going to compare hypothesis test to confidence intervals and see how that works. All right, so once again, here's our state plan to conclude. So remember, when we're doing a hypothesis test, just like we're doing confidence intervals, you probably just want to put this big old cross on your paper, and then just remember to fill in each section with our stating, our planning, our doing, and our conclusion. All right, so here we go. Here's an example. So according to the Centers for Disease Control and Prevention, or the CDC website, 68% of high school students have never smoked a cigarette. So it looks like we're working with a proportion of students who have smoked cigarettes, or who have never smoked cigarettes, I guess. Anna wonders whether this national result holds true in her large high school. She surveys a simple random sample of 150 students from her school. She gets responses from all 150 students, and 90 say that they have never smoked a cigarette. Is there convincing evidence that the CDC's claim does not hold true at Anna's school? So it does not hold true. Use alpha equals 0.00 or 0.05. All right, so we're looking for convincing evidence for a claim. That's what tells us we're doing a hypothesis test. Another key indicator is they give us an alpha value. So we go ahead and we draw our big old cross here. And we start by stating what we know. So we're working with a proportion. So P is the true proportion. Haven't even thought about what it stands for yet. I'm just writing true proportion. And now let's see, of high school students who have never smoked a cigarette. Next up, let's see, we've got a null hypothesis and our alternative hypothesis. Null hypothesis is always equal, and what does it say it's equal to? Well, it says it's equal to 68%, so 0.68. And we just want to know if this claim does not hold true. All right, so that means it could be greater than or it could be less than, so we're just going to say is not equal to 0.68. And not equal to is what tells us that this is a two-sided test. All right, but our calculator, if we're doing this in the calculator will take care of it with the p-value and whatnot. All right, and let's see, what else do we have? We've got our p-hat is 90 out of 150. So that means our n here was 150. We are doing a one sample. She only took one sample. We're working with p's, so it is a z test for p. All right, and let's see, we had a simple random sample right here, so it says random sample, so we're going to say random sample stated check mark. Next, we're going to look at our normal distribution conditions. So remember, this is our p naught. Our original here is p naught. So our n was 150, so we got 150 times 0.68, and 150 times 1 minus that, which is 0.32. And we want both of those to be bigger than 10. I don't know what those are off the top of my head, but we do need the numbers for those. So we're just going to type into a calculator. All right, come on, baby. There we go. 150. It's a little slow for today. Times 0.68 gives us 102, so the other one will be 48. The reason I got that so quick is these two have to add up to 150. This is greater than or equal to 10. This is greater than or equal to 10. So those both work out. So that means we have an approximately normal sampling distribution. I would hate for you to lose points on the AP exam just because you're too lazy to write out words. So just write them out, please. And our last one, independence. Our n here is 150, which surely is less than 10% of all students at, and let's see, who are we talking about here? Anna, there we go, at Anna's school. All right, so as long as there are more than 10 times that 1,500 students at her school, which it's a large school, it said it was a large high school, then it's probably true. We're probably okay there. Next, we go to our calculator, and on our calculator, this is a one prop z test. So we go back to our trusty friend here, stat test number 5, one prop z test. And let's see, our P naught was 0.68. That's what we start off with. We had 90 people out of 150 said that they had never smoked. We want to just have different than, not equal to is our alternative hypothesis, and calculate, and we get negative 2.1 and 0.035 and so on. So our z is negative 2.1. And there was some zeros after it, and our p-value was 0.03, and what was after the rest of that? 569. So 0.035 is probably plenty. We can round that and say 0.036 if we want, but that's fine. Or just have to be able to compare it to alpha, which we said was 5%. I didn't write it down, but probably should have put it right there, alpha 5%. All right, so our conclusion. So we say since our p-value, which is 0.035, is less than 0.05, which is our alpha, well, p is low, so we reject the HO, that p equals 0.68. This means we have significant, we don't just have a little bit, we have significant evidence that, and we're going to write out the alternative hypothesis here, but just in context. So we're going to say the true proportion of students at Anna's school who have never smoked is different, or not equal to, different from 0.68. All right, and there's our test. All right, I know that takes a little bit. I mean, that took, what, 5-6 minutes just to do all that? And, I mean, I guess I'm a seasoned veteran. I've done this a lot. But with practice, guys, this gets easier and easier. And it's just a bunch of fairly routine steps over and over and over again. So this is a two-sided test, meaning this p-value, like when we actually find this area, let's see, it was -2, so it was like way down here. It's actually finding this area, and it's adding to it the symmetric other side of this normal curve over here. Because it's not equal to, it's adding both sides together. All right, so for the cigarette problem, the problem that we just did, calculate the confidence interval at a 1 minus alpha % level. So let's say 1 minus 0.05 times 100% gives us 95%. So we want a 95% confidence interval based on our data. So our data was that, let's see, p hat was 90 out of 150. So let's go back to our calculator and see what happens when we do the confidence interval here. We'll just see how that compares. So we have a 1 sample, 2 sample z interval. Where's 1 sample z interval? 1 prop z interval. There we go. 1 proportion z interval. There we go. And let's see, we've got 90 out of 150, and we're going to have 95% was our 1 minus alpha level. And we get that it, let's see, we're going from 0.5216 to 0.678. So our interval did I write that down right? Let's see. 5216.6784. Yeah. All right. So now is 0.68, which was our p naught, in this interval? All right. Well, it looks like it's going to be just outside of that interval. All right. So the answer is no. It's not in the interval. So that means if this is our sample information, which it was, then that means this is not a plausible value. So p equals 0.68 is not plausible, which agrees with our answer. So we said we were rejecting that p equaled 0.68, and our confidence interval, if we do the same confidence interval from the same information at the same level, we get the same answer. Now, I guess the question is, will that always hold true? And the answer is yes. It's just a matter of picking the correct level. So with the two-sided test, yeah, you're just doing the 1 minus alpha % confidence interval, and it will get you the same thing. But if it's a one-sided test, I guess I put sided, there we go, it's not quite the same. All right, because all that alpha is on one side, and if we make an interval, we want both sides. So it's actually 1 minus double alpha, and we get a confidence interval. Because when we're doing the one-sided test, we're really just looking for this one side. And if we want to make an interval, we need both sides. So we have to kind of change it to a two-sided test. So we have to double the alpha, because this right here was alpha for the one-sided test. So this right here would also be another alpha, and then this would be a 1 minus 2 alpha confidence interval from there to there. All right. I'm just showing you they're saying the chances are nothing like this will show up on the AP exam, but I am just showing you they are equivalent to each other in a certain degree. All right, so here's another quick example of a two-sided test. So again, my 80% making trash get ball shots. So my P is that it's 80%. My alternative, you believe the true proportion is different. So that P is not equal to 80%. And let's see, we've got our alpha here. We've got our P hat is, I make 187 out of 250. So that's my N. And it is a multiple choice question, so I'm just going to go straight to my calculator and plug in the numbers. So stat, test, and we're doing all one prop Z test. And let's see, we've got 0.80 as my null hypothesis. Our alternative, let's see, we have our sample is 187 out of 250. And we've got not equal to still. And calculate. All right, there is a draw feature here. You can draw the graph that I sometimes draw. And here we go. There's our p-value, 0.0398. So base 0.0398 is our p. All right, so that is less than 0.05, which is our alpha. So p is low, so we are going to reject the HO. All right, so reject the HO, reject the HO, reject the HO. It's one of those, and there's our p-value right there. So it looks like we have D as our answer. All right, so that's how we do our two-sided test. We do it the same side as our one-sided test, but there's just some other things that we can do with comparing it to confidence intervals afterwards. This is the end of 8.2, so go ahead and get started on that homework for 8.2.